Istanbul straddles the strait between Europe and Asia. Time and time again, it's shaken by unpredictable, strong earthquakes.
Istanbul is extremely at risk. Over the past 50 years, this megacity has grown from a population of about 1 million residents to more than 15 million.
It's a race against the clock, posing a challenge to disaster management teams and local residents. The city lacks buildings that can withstand quakes.
95% of all houses would have to be demolished.
We face a terrible situation. It's not just the quake itself, it's the aftermath too.
Is it possible to predict the next big earthquake? Seismologists are developing a new method.
The best case scenario would be to put out a sort of fever curve, where every day we could estimate if there's a higher or lower risk of an earthquake.
But forecasting too far in advance has risks of its own.
People would storm the banks. They would storm the stores. They would turn on each other. Are there security forces or a plan in place for this type of scenario? No.
The countdown for seismologists and emergency responders is on. More than 15 million people live in this coastal city. And it's becoming increasingly crowded. The Bosporus Strait divides Istanbul into a European and an Asian side. The region is particularly prone to earthquakes. In 1999, less than 100 kilometers from the city centre, an earthquake strikes. It's one of the worst in Turkey's history. At least 18,000 people die, hundreds of thousands are left homeless. Emergency responders are often too late. There is no working emergency plan or early warning system in place. Thousands of buildings collapse like houses of cards. Sandy subsoil and shoddy construction are to blame. Seismologists expect a similarly powerful earthquake in the coming years, this time right off the coast of Istanbul. A good 1,700 kilometers away, at the German Research Center for Geosciences in Potsdam, scientists monitor earthquakes all over the world. Seismologist Marco Bohnhoff and his team are studying the city on the Bosporus. The Earth's crust is especially unstable in the region.
Istanbul is extremely at risk. Over the past 50 years, this megacity has grown from a population of about 1 million residents to more than 15 million. And unfortunately, just off the coast of Istanbul, there's an active plate boundary. And from what we can tell, it's under enormous stress.
A tremendous amount of energy is currently building up underground. Like all continents, Europe sits atop tectonic plates. Directly in front of Istanbul in the Sea of Marmara, the Eurasian plate meets the Anatolian plate, forming a so-called fault zone. Typically, these plates push past each other bit by bit, and gas bubbles rise from the ocean floor. We can see this from footage taken by a French, German, Turkish research team. But right off the coast of Istanbul, the plates are stuck. We don't see the usual gas bubbles. At spots where the Earth's plates cannot move alongside each other, the pressure builds, energy accumulates. If it discharges, the plates could move forward by up to 5 meters at once, triggering a violent earthquake right in front of the coastal city. The government forecasts 30,000 to 80,000 deaths could result. Experts even say a tsunami is likely, with waves as high as 4 meters. Seismologists predict the earthquake will have a magnitude of at least 7. Earthquakes are measured on a scale of 1 to 9.5. Quakes with a magnitude of 4 are felt by most people in the area. A magnitude 7 quake is considered particularly strong. Bohnhoff's team wants to use a new method to predict powerful earthquakes like these in the future.
There's a series of indicators we can observe before an earthquake strikes. And if we can systematically record and evaluate them automatically in real time, it would essentially be possible to look at the fever curve of a fault zone 24 hours a day, and then issue warnings when necessary.
That would be revolutionary. So far, early warning systems around the world react, at most, a few seconds beforehand. So-called seismographs register the less powerful primary waves of an earthquake, sending a signal just seconds before the destructive secondary waves start. Mexico City uses such a system. In 2017, there were 2 particularly strong quakes here. About 20 seconds beforehand, residents were warned via public loudspeakers, saving thousands of lives. This was possible because the epicenter of the quake was far outside the city. In 2011, Tokyo experienced one of the most severe earthquakes ever seen worldwide. The city's residents were warned via television, radio, and the internet nearly 80 seconds beforehand. In those precious seconds, the city can shut off gas lines, switch traffic lights to red, and bring trains to a halt. Istanbul also has an early warning system, but it's only for the disaster management team, and the warning period is limited to just 5 seconds. At the Disaster Coordination Center, that is not enough time to warn residents.
Because that time span is so short, people would not be able to escape in the event of a quake. That's why our system is limited to preventing accidents or fires, for example, by automatically turning off the gas.
Employees of the local transport system and gas utility, as well as firefighters, are often on standby in case of an earthquake. They also get some help from the computer software ELA. Depending on the magnitude and location of the quake, the program immediately calculates the number of potential deaths or collapsed buildings.
Then we have to compare the computer's estimation with what's actually going on. To do this, we use information from the team that's on site, for example, the fire department. Then we can be confident we're sending the right team to the right place.
Residents must also be prepared. At the Disaster Training Center in Kozyatağı, an 8th grade class is running through drills today. So how close is the danger?
This is the North Anatolian Fault Zone. We are only 12 kilometers away from it here in this district.
That means a quake would be felt especially strongly here. A simulator generates a quake with a magnitude of 6.7. The children only have a few seconds to duck under the table. It's important they remember to protect their heads. When the quake is over, the students can run outside, but not before turning off gas and electrical appliances to prevent fires.
I only knew a little about earthquakes before this, but now I've experienced it and understand what to do.
The instructor, Cenk Tankal, recommends always having an emergency backpack ready to go, equipped with water, a flashlight and a first aid kit.
Professional aid won't come for the first 72 hours of a disaster. Therefore, we must be prepared for survival until help arrives.
But these tips are only useful if buildings and infrastructure can withstand the earthquakes. On the European side of the city, a subway line is being extended. Civil engineer Mustafa Murteza is supervising the project on behalf of the municipality. In the district of Katana, the tracks emerge above ground and cross a bridge. It is supposed to be safe for an earthquake up to a magnitude of 7.5, but the soil poses a risk.
We have to cover a long distance here, but the ground is very muddy and unstable. This is dangerous during quakes. That's why we dug very deep into the earth to connect the bridge's pillars with stable ground.
A 70-meter-long steel structure will anchor the bridge to firmer ground. The subway control center. This is where emergency plans should take effect in the event of a quake. Stop elevators, switch escalators to move up only, slow down and evacuate trains. And then, while we're filming, this happens. A moderate earthquake with a magnitude of 5.8 hits the city. It's the second earthquake within a matter of days. There hasn't been a situation like this for many years.
I was at work. At first I thought something struck my chair. Then it started shaking. We were evacuated immediately. Now I'm here to pick up my child. Good luck.
Cell phone service is disrupted. Those who can try to reach their friends and family.
The houses here are all old, so we were very afraid.
I can't reach my family. The lines are down. I'm also afraid to go home.
I'm nervous, very nervous. I can't even picture what the big quake would be like.
Fortunately, there are no deaths or injuries. But many buildings, including this minaret, are damaged. One day later, Typhoon Kahraman is the head of earthquake risk management for the city. He's faced with a big challenge. The city's warning system did not activate during the quake.
You can't say the system worked as it should have. We have 10 stations at the moment, but we aren't receiving a signal from any of them, not even yesterday. Our task now is to build more stations and repair the 10 we already have.
Turkey's Conservative Party ruled Istanbul for 25 years until the summer of 2019. Kahraman says the party did not do enough to prepare the city for earthquakes.
Unfortunately, we cannot say that Istanbul is prepared for an earthquake today. There are still buildings here that are in danger of collapsing. After all, even the 5.8 magnitude quake caused major damage.
The new city government wants to set new priorities. Today, Karaman hosts representatives from the Magda Foundation at City Hall. For about 2 decades, this group of scientists, merchants and craftspeople has been trying to prepare Istanbul residents for the next big earthquake. Traumatized by the 1999 quake, they do not want to leave their fate in the hands of the state alone.
Our mission is that within the first 72 hours after a quake, everyone is active in their own neighbourhood.
We want to train 4 to 5 volunteers in each district to form a civilian disaster rescue team.
The new city administration wants to work together with the foundation. For disaster management expert Özden İjik, this is a ray of hope.
We have come to the right place. He will support our projects, develop them further, and he also has plans of his own.
The earthquake was a wake-up call for the whole city. At a panel discussion, the Foundation Magda informs residents about the dangers of earthquakes. There's quite a bit of interest. Özden İjik tells them what they must avoid at all costs is panic.
When combating a disaster, the most important asset we have is people. But only if those people are prepared and can act reflexively. If they are not prepared, then they become a liability because they panic.
Back in Potsdam, Germany. During laboratory tests, seismologist Marco Bohnhoff has a breakthrough. He uses various types of stone to simulate earthquakes.
In the real world, there might be 100 or 200 years between 2 strong quakes. We don't have that time. So instead, we simulate these processes at an accelerated rate. We increase the pressure relatively quickly and then retrieve the measured values so we can do our calculations. Ultimately, we can recreate a complete cycle from one quake to the next within a few minutes.
Bohnhoff tests it out with a sandstone sample. A press applies an enormous amount of pressure to the stone. The machine simultaneously registers acoustic signals that reveal what is happening to the stone internally. Slowly, the machine increases the pressure on the stone. It's as if 30 trucks were stacked up on one finger. On the surface, it appears the stone hasn't changed, but the acoustic signals on the monitor show another story. It's beginning to fracture. More and more cracks become visible, like small, miniature quakes. 15 minutes later, the stone breaks. Marco Bohnhoff says the same logic can be applied to large-scale earthquakes.
We're seeing all of this foreshock activity before the point of fracture. And since that's similar for all rock samples, we're hopeful that we can apply this method.
Many mini-quakes to signal a larger earthquake is coming? Was this also the case with the September quake in Istanbul? Scientists from all over the world conduct research at the German Research Center for Geosciences in Potsdam in the hope of predicting when earthquakes will strike. In addition to Turkey, Greece and Italy are 2 danger zones in Europe. The main trigger is the African plate, which is pressing northwards towards the Eurasian plate in the Mediterranean. In 2016, an earthquake rattled central Italy. Nearly 300 people died. One issue was the collapse of many old buildings. This was not the case in Japan, which experienced a 9.1 magnitude earthquake in 2011. There, nearly 20,000 people died, most from the resulting tsunami that slammed into the northeastern coast of the country, devastating the area. Researchers say adapting infrastructure is crucial.
The earthquake that struck Japan in 2011 is a good example. Indeed, there was a lot of damage related to the tsunami, but the buildings withstood due to compliance with earthquake-resistant standards.
Japan invests a lot of money in earthquake-resistant construction, for example, offering subsidies for buildings with shock-absorbing dampers. The money for this kind of technology isn't available in Istanbul.
Three factors must be considered. First, the likelihood an earthquake will strike. Second, the number of buildings and people. And third, the quality of the construction, or how vulnerable the buildings are. So a hotspot, in other words, a place where damage could be particularly great, has these three factors. And we see that in Istanbul, but also in cities like Lima, Quito, or Mexico City.
The biggest challenge now in Istanbul is limiting the potential damage of a mega earthquake. In the southwestern part of the city, the Bakırköy neighborhood is particularly at risk. Özden İcik from the Magda Foundation has worked here for 12 years as a disaster prevention coordinator. She surveys the area with Oğuz Gündoğdu, a seismologist.
The houses here are very old. It's imperative we push for change and rebuild.
After the September quake, 2 buildings were evacuated. The facade shows significant cracks. The residents are alarmed and upset.
One of the buildings will be rebuilt, but the owners simply cannot agree on what to do with the other one.
If a building is reported to the city as unsafe, it should be torn down. But there's not enough funding to build anew. That's why unsafe buildings are still inhabited.
The government only cares about prestige projects. It doesn't care about how people really live, but they should.
It's not just about the quake itself. It's the immediate aftermath that would also be terrible. The fire department warns fires could be ignited by natural gas leaks. There's an aviation fuel tanker and gasoline depot near here, and yet there are still no precautions. The fires that could occur after a quake are the biggest risk for Istanbul.
We have no time to lose. But our government in Ankara prefers to plan an absurd new canal through Istanbul. We must immediately prepare for a quake, but they just aren't listening to us.
No other major city in Europe has grown quite as fast in recent decades. What is lacking, however, are earthquake-resistant residential buildings. In recent years, the Turkish government has repeatedly tightened building regulations. But the Chamber of Civil Engineers is skeptical of the construction industry. Its chairman, Cemal Gökce, stresses that just because a building is new doesn't mean it's safe from earthquakes. It's a major sore point.
Until very recently, inspectors were chosen and paid by the builders themselves. How independently can you inspect the person who's paying you? At least since the 1st of January 2019, inspectors are now selected through an electronic system. But even that does not suffice, because they're often not trained well enough. They don't have special certificates. A simple diploma is enough to get the job. We have a serious problem with construction supervision in this country.
The city is growing rapidly. As a result, it is becoming more and more crowded, and the risks of severe consequences from an earthquake are increasing.
That's the situation we're in right now. It's a crime, isn't it? Can one really live in a city like this? The government is eyeing these open spaces already. There's sure to be construction here. It can't go on like this.
Meanwhile, the State Disaster Management Authority, ARFAD, is raising awareness about the risks posed by earthquakes with an elaborately produced TV commercial. The message, prepare for disaster so that your neighbourhood stays safe. How to go about this, however, is not specified. Instead, the authority promises educational campaigns. The reality on Istanbul's streets is not as idyllic as the commercial. In actuality, there are constant traffic jams and more high-rise buildings. The new city government knows this all too well. It is seeking solutions and has invited German seismologist Marco Bohnhoff to Istanbul. Scientists from all over the world are joined by local rescue teams and associations to discuss the current situation. Bohnhoff delivers the opening speech, a sign of how much his work is appreciated.
The current knowledge of the Marmara Fault indicates a maximum expected earthquake magnitude of 7.4. Of course, this would not exclude a larger event, as we have learned so dramatically in Japan in 2011, but based on historical data, this is probably a solid measure.
Over the years, Bohnhoff's team has worked with Turkey's Disaster Management Authority to set up 7 measuring stations in the Marmara region. Earthquake safety is a top priority for the city's new mayor, Ekrem İmamoğlu. He is in close discussion with Bohnhoff and other international scientists. Their research will be incorporated into the new earthquake roadmap for Istanbul.
I'm convinced this is an issue that the whole world must solve together. Istanbul's biggest problem when it comes to earthquakes is the safety of its buildings. Nearly 50,000 buildings are at risk. Even a mild quake can damage them. This poses a huge threat to the lives of tens of thousands of people. The answer is not only to demolish houses and build new ones, but perhaps to strengthen existing buildings as well. We must use this time very wisely to find quick and practical solutions so we can save people's lives.
Engineer Alper Gökce is also committed to finding solutions. But Gökce is not working on predicting if an earthquake will strike days or hours ahead of time. He's focused on the seconds before the quake.
We developed an early warning mobile app that alerted users about the Istanbul earthquake in September. So we've proven the app works. I'm now here to get support for it from the city.
Alper Gökce's appointment was put off until a later date. The fear of a quake has been propelling him forward for years. Istanbul doesn't have an early warning system like the one in Tokyo or Mexico City. So Alper Gökce took matters into his own hands and developed a mobile app in 2017. It's designed to send a warning signal to people in the Istanbul area a few seconds before a major quake. The app can be purchased for the equivalent of around €2 a year. So far, Gökce has set up 6 measuring stations in the Marmara region using his own funds. Today, he is monitoring his station in the Büyükçekmece district. The sensor registers tiny tremors 3 meters deep. In the event of an earthquake, it measures the less powerful primary waves of the quake. It sends a signal to app users 5 to 25 seconds before the stronger and more destructive secondary waves. The warning time increases the further you are from the earthquake's epicenter.
Sistem kendini ispat etmiş bir sistem.
The system has proven itself. But if there's only one station per location, there's a risk of false alarms. For cost reasons, I've only set up one system at this spot, but it would be better to add 1 or even 2 stations every 3 kilometers and set up a whole network.
But he doesn't have the funds for that. Each new station costs about €25,000. Currently, about 5,000 people have downloaded his mobile. Only a fraction in comparison to Istanbul's 15 million residents. But Gökce believes in what he's doing. Every second counts.
In 10 seconds, you could take shelter with your children. If you're driving a car, you can park it safely. If you were about to go inside a building or drive through a tunnel, you'd decide against it. These are seconds that save lives.
But seconds are not enough for German seismologist Marco Bohnhoff. He wants to be able to warn the population hours before a quake. He is out on the Sea of Marmara just off Istanbul, exactly where a fault zone far below the surface could trigger the next big quake. On the island of Büyükada, Bohnhoff has set up a measuring station to help with his forecasts. But the station is hardly sending any signals at the moment. That's a problem.
This is the largest island off the coast of Istanbul, and these are predetermined measurement sites because they're closer to the fault zone.
The team is headed to the highest point of the island. A summit in the middle of a nature reserve. Here, seismographs were installed 300 meters deep into the earth and covered with concrete. Using acoustic signals, they register the smallest tremors that do not reach the surface. This way, even mini earthquakes are recorded. The depth of the seismographs plays a critical role.
First, we have to try to get beneath the surface because in a metropolitan area like Istanbul, there's a lot of background noise from infrastructure, wind, and weather. That's bad for us because we want to measure the signals as cleanly as possible. That's why we have to go deep below the surface. But drilling deep down is expensive, and we have to drill at least a few hundred meters. So in this case, the compromise between the cost of drilling and meeting our requirements is 300 meters deep.
Construction, around €300,000, was financed by the German Research Centre for Geosciences, the Turkish authority AFAD, and international donors. Didem Acharel remembers how intensive the process was.
The drilling here took a total of 9 months. The ground is made from very hard stone, so drilling into it was very difficult. It was also a mammoth task to bring these huge machines to the island. And then the drill heads of the machines kept breaking off. I think we had to replace 10 of them. The drilling company hated us by the end of it all.
The data from the seismographs is sent in almost real time via the internet to the Disaster Management Authority AFAD in Ankara and to Potsdam. The team must now figure out why the signals are failing to send. A US company manufactures the sensors. They are used in earthquake zones all over the world. Technician Sergio Valenzuela has come all the way from the US to help with maintenance.
We have some problems with the station. Seems like it's not sending the data to the central station. So we try to figure out what's the problem. Seems like it's the RAM. The digitizer has like a RAM inside. When it gets full, it will stop acquisition because it's how it's designed.
Because the seismographs are embedded deep underground, they cannot be swapped out. Valenzuela can only activate them by remote control.
They didn't get here.
Bohnhoff phones his colleagues in Potsdam to find out if the data has arrived.
We repaired the data logger. We know the data arrived in Ankara, and in 5 minutes we'll know if it arrived in Potsdam, but everything looks good.
Mission accomplished. The data finally arrives in Potsdam. Meanwhile, app developer Alper Gökce has found a backer for his early warning system. A renowned Istanbul geologist wants to further develop his app.
Professor Cenk Yaltırak wants to use cell phones to measure the shaking during an earthquake and compare it with the measurement data on site. Something like this has not been done before. We want to combine these two functions in the app. Until now, it's not been possible to measure how each building reacts individually during a quake. But with cell phones lying around the house, we could measure that.
Gökce meets the geologist at Istanbul Technical University. They discuss how the app could be used to estimate damage after a quake. A few years back, geologist Cenk Yaltırak was also working on a warning system to predict earthquakes. That's no longer his priority because he considers it dangerous.
If I could predict now that in 30 hours there will be an earthquake, how would they control the money in Turkish banks? It would flee abroad. People would storm the banks. They would storm the stores. They would turn on each other. Are there sufficient security forces to prevent something like that? Is there a plan in place? No, there isn't. Therefore, even if there was a way to predict earthquakes, our society would not be set up for it. Because then you would need 2.5 square meters of space outside per person. But there's no space in Istanbul. We don't even have 75 square centimeters per person. Just go to the city center. The streets are 2.5 meters wide, the houses 6 stories high. If one house collapses, the whole street is blocked. If fire breaks out in just one house, it spreads to all of them.
Only a few months have passed since the last quake in Istanbul. On the 24th of January 2020, another earthquake strikes Turkey. This time in the eastern part of the country. The quake is almost 30 times stronger than the September quake in 2019. At least 90 buildings collapse and 41 people die in the Ilazi region. Survivors and rescue workers brave overnight temperatures of -8 Celsius. Emergency units travel from Istanbul. The rescue work takes days. Geophysicist Marco Bohnhoff doesn't have much time left. Unfortunately, that's exactly what research requires. But he does have new findings. The results of the September quake are in. His thesis seems to be correct. Under the Sea of Marmara, many mini-quakes accumulated until the bigger quake with a 5.8 magnitude struck.
And the big question is whether these fractures, the foreshocks, are signs of a larger earthquake.
Researchers don't yet know if this is a pattern that can be applied to all quakes, but the indications are growing. Bohnhoff estimates that it will take another 1 to 2 years to see if the method is proved correct. Only then will it be possible to develop a reliable forecasting system.
The best-case scenario would be to put out a sort of fever curve, where every day we could estimate if there's a higher or lower risk of an earthquake. Residents would start to adjust to this. It would be like what we see with forecasting extreme weather. This is not yet the case with earthquakes, and there's a long road ahead to get there. But this is what we're aiming for, and we're working to improve this situation.
The people of Istanbul only have a real chance if priorities are set. Earthquake-resistant buildings, public warnings seconds before a quake, and a longer lead forecast. The researchers' work remains a race against time.